Hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms and how I could probably improve it. I don't know. So, the very last video was, well, 17 days ago, and I say that because right now the date time is 2025 September 26th, and yes, again, I know that I promised that I would do this in the next 3 to 4 days, or at most maybe a week or so, but bit of an excuse is that maybe I was just too busy. I've been busy doing some other stuff, but the main reason for my tardiness is that I really could not figure out how to quite optimize it. And although I have managed to make a version of chaotic dynamic genetic algorithm, it has not been so easy. Actually, it's starting to think maybe it's almost impossible to reach the true ceiling, or true ceilings for that matter, whilst doing chaotic dynamic genetic algorithm. Mostly because of probably mostly because of all the reasons that I listed towards the end of my last video. And in order to tackle that, I have been trying a lot of different combinations for the hyperparameters, and I still have not managed to come up with a set of hyperparameters that would yield true ceilings for the entities. And I haven't actually done a proper grid search, but I've done something similar. Think of it like a random grid search, which is probably why it took so much time, and why it was compared to doing a grid search, so why it was so inefficient and ineffective. Maybe I need to find a way to do a proper grid search, which would mean that I would need to refactor or just edit bits and pieces of my code. But anyway, the purpose of today's video log session is to talk about the thought process of what I did and what I have been doing, and going forward what I should do in a more systematic manner, so that I could document my findings, document the findings again in a more systematic manner, so that it all makes more sense. I don't expect everything to make sense, I just want more things to make sense. And that's the purpose of this video. So, progress update is that, well, I have managed to hit the true ceiling, in which case a true ceiling for 100 items using the preset values, and the true ceiling being 2865. And in my last video I believe I demonstrated or showed that the results that I showed back then were very close to 2865, as they were somewhere around 2850 or 55 or 40 or 35, you know, maybe, yeah, or maybe sometimes 60 as well. But this was well, achieved by either usually achieved by increasing the number of blips, or increasing the max population. So which isn't technically cheating. If I wanted to call it cheating, I would I would call it cheating if the maximum population was set to more than 400. But in this case, the highest number for the max population that I used was only 200, and the highest number for the max blip, or the total number of blips, was 300 and maybe 400 as well, depending on how you look at it. I'll show that. I'll make sure to share it, probably, in the future videos. But so I wouldn't technically call it cheating. But what I want to get at is that I would like the total number of blips to be 100, and the total number of entities, the maximum population, to be 100. You know, yeah, and I would like this setting to be able to produce true ceilings preferably all the time, but I know that's not realistic, so maybe 1/3 of the time, or maybe even 1/5 of the time. But so far that wasn't the case. So, and this was when I was all of this. I'm talking about the true chaotic, or let's just delete true, just chaotic gen algo. Okay, so I have managed to do that, and in which case it and then yeah, so the summed utility plot looked like this, something like that, for the top entities. And for the I'll just bear with me, I'll share these plots in my future videos, but for this video I just want to talk about, you know, the general plan. And the top 10% would look something like this, very close or sometimes the same, which means very high level of convergence. And then the top 50% looks something like this, and then the tail entities would look something like this. So that's, I have managed to do that. So that's good. At least that's what I thought. I mean, oops. Summed util plot. So that was done. So, and then after about a week of struggling with the trying to make the version, trying to make the chaotic dynamic version. I'll just write that. I'll just type it, since this is easier. Chaotic dynamic genalgo. Alright. Smaller, please. Yeah. Genetic algo. And so far, I've managed to, no, why am I doing that? So far, I've managed to get the sum utility plots in the shape, well, first of all, in the shape that I want, or in the shape that was usually observed, which is, simply put, something like this. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, maybe not. Maybe something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So something like that. But the thing is, the only problem here is that this didn't happen. It would go something like this. Or, I love ors, don't you? Or it would look well, oh my god. Or it would look something like there we go, and there we go, there we go. If keep in mind, the red horizontal line is the true ceiling, which is 2865. Let me just write that again, 2865. So with the version of chaotic dynamic genetic algorithm right now, I would have a summed utility plot that looks like this one, the 10 steps, because there are 10 stages, which is 10 items here, for 20 items here, for 30 items here, and on until until this bit is 100 items. I would have something like this, or I would have something like this. I'm not even being lazy here. The plot would sometimes literally look like this for the top entities, and this is also for the top entities, the head entities. Oh yeah, I forgot, I should call them heads. Like for the heads, and this is also for the heads. I forgot the S. Oh for the heads. So, or sometimes I'm having a lot of ors today, aren't I? Oh my god. Or sometimes I should put this somewhere here. Yep. Or sometimes the plot would look well, more of a rounded staircase. Something like that, but not reach the either be nowhere near the top ceiling, true ceiling, or well, kind of close, but not really. Which by that I mean something like the head entities would be like 2800 or something like 2810 or sometimes 2840. You get what I mean. So not satisfactory. I mean, to some degree it is quite satisfactory. I was satisfied with the fact that I have actually managed to make a version of this, of chaotic dynamic genetic algorithm, but a version of it. But some things still need to be optimized, and I still need to know the right hyperparameters, hyper-P's, in order to guarantee that I get true ceilings. In which case it would look something like 3, 4, 5, 6, 7, 8, 9, and 10. So that's what I want. This is 0, and this is true ceilings, and where the what is it? The plot for the top 10% would look something like this. Yep. And for the top 50% would look something like this. And for the tail entities, it would look something like, give me a color. It was something like look something like this. So this is what I want, right? Give me gold and I'll put a star here. I'll put 2 stars. This is what I want. This. But in order to do this, there are still a lot of things, I think, for me to get a grasp of. Well, number one, I don't think the blips are enough. So by that I mean, remember it's so give me the text again. So blips, as in a unit of time step, it's a unit for the time step that I have named. I know it sounds silly. Blips, or max blips, let's say. Max blips is set to usually set to 100. It could be very rarely be 150. Kind of more often than when it is 150, it is at 200 or 300 or 400, 400, and at most I've done 500. 500 is the most I've done. And the maximum population is, well, I usually set it to 100, but if I'm frustrated, I set it to 200. Anything more than 300 is 300 plus is very dangerous, since I haven't really optimized things yet, and my laptop feels, well, it would sound like it's trying to take off or something, because the fan would just start whirling and churning and just make loud noises, because the CPU is usually at 100% capacity when this happens, when I set it to 300 or plus. Yeah, these are the first two things that I have to consider. So if I were to talk about the concept of time, or blips, first, the way it works is the way chaotic true, in brackets, true chaotic genetic algorithm and chaotic dynamic genetic algorithm works, is that the concept of the concept of time, and of course and therefore rather time step or unit is different. Now by this I mean that if I were to do this if I were to do everything in a dynamic genetic algorithm, or vanilla, in brackets, vanilla, oh my god, why do I keep on using brush? Okay. The reason I say that the concept of time is different here is that if I were to do dynamic genalgo or just vanilla, is that how you spell vanilla? Yeah, I think so. Vanilla genalgo. Maybe I'm wrong. How do you spell vanilla again? I'm sure I searched for it. Oh, it's 2 L's. Well, I'm so bad at spelling things. Vanilla genalgo, or even pseudo chaotic genalgo. They all mean that I can do this using well, just Python. I would be using Python, as opposed to using Python and then using Nutka to compile everything into a binary executable and doing things. So I'll be using Python, and everything would be anything but multi-threaded or concurrent. I'll be using Python and not multi-threaded, concurrent, parallel, etc. You name it. Everything fancy, I'm not using that. So when this happens, here, when I was doing dynamic genetic algorithm, the unit for the time step was called a generation. And vanilla genalgo, same. So these two, same time step units. And as soon as I moved on to doing pseudo chaotic genetic algorithm, I changed the name for the time step, because not every entity does something in the same loop. So generation became blips, as in an entity does something in a blip, because lights blip, computers also kind of blip, where there are LEDs or other devices. So anyway, I call them blips. in the pseudo chaotic genetic algorithm. But as soon as but this blip is not exactly the same as a blip. It's not exactly the same as a blip in true chaotic gen algo, because, well, so far up to this point everything was done in a loop. When I say everything, every entity that was initiated were included in this loop of however many blips or generations that I set, the total generations or total number of blips that I set in the hyperparameter. But as soon as I moved on to doing true chaotic genetic algorithm, where, if you remember, what is this? Where everything is just doing its own thing, where every entity is doing its own thing in a non-synchronized way in terms of time. So there's no way, there's actually no way for me to have all the entities that are included in this said loop go through the same time on the same scale, or in a there's no way to guarantee that the entities would, let's say, experience time in a shared spectrum or a shared passage of time, or in a shared manner. They're all doing, each entity is doing it, his or her or its thing. So in order to tackle this, or in order to be able to organize this, I've set the blip in a way so that each blip is made up of sand grains. Now, I just called it a sand grain because, well, I'm sure people know an hourglass, and then there will be these sand grains. And once everything falls, like, yep, now we have the hourglass, but all the time's up. And when this happens, one blip has actually finished. So when that happens, I would flip it again and begin a new blip. And either at the end of each blip or at the beginning of each blip, all the scores, all the summed utility values will be well, recorded and, well, maintained until the where is it? until the world.bin is over, as you can see here, the world.bin, because there are two main parts, entity.bin and world.bin. So each time all the sand grains have been have dropped to the bottom of the hourglass, a new blip is started. But then again, what do I mean by a sand grain dropping or dropping or time passing? A sand grain dropping would mean that time passed. So what do I mean by that? Each time an entity does any one of these three things, M for mutate, L for learning, LRN, and P for procreating. Each time an entity does any one of these things, it would use up one sand grain, meaning that the sand grain has fallen, like that. So when all the sand grains have fallen, or all the sand grains have been used by the entities, a new blip will be initiated, will be started. I am so bad at drawing an hourglass. A new blip will be initiated with new sand grains for the entities to use for their entity events. And of course there's the C, which is short for chill. Chilling and just existing. This does not use up a sand grain. And this method, because it's in a class, it's in an instance of a class, the purpose of this was to mimic how some entities would just end up doing nothing during that blip whilst in the loop, while the loop is going on. So that was the whole point of this method. Just yeah. So, and as a result of doing this, implementing these concepts and features, the concept of time changes from, well, it goes from absolute concept of time, changes from time being absolute or fixed, as in shared by all entities, fixed, shared, and experienced by all entities all at the same time, to time, and also the time steps being relative. I don't think these, but one thing to note here is that I don't think, just because of the way I phrased these two concepts, these two ideas, should not or may not mean the absoluteness of time and the relativeness of time as well, should not mean the same things in physics, but it kind of feels that way. Because everything is just random, and it feels random, rather, I should say. And it feels random because the world .bin and the process that is running world.bin is somewhat detached from the processes all the processes that are running entity.bin. So process 1 entity 1.bin, process 2 entity 2.bin. So something like that, and on until like there are 100 processes. Process 100 running entity 100.bin. So they are running somewhat simultaneously, but they're not. These processes that are running all the entities on an individual basis are not entirely included, or are not entirely within the confines of the world.bin. All world.bin does is, or are rather, that it keeps record of all the scores, of all the sum utility scores. It also resets the blip when all the sand grains are used up by the entities. It also, while it resets a blip, each time it does that, it will also, the world.bin will also make a certain number, will also create a certain number of sand grains so that the entities can use it. Yeah. So that was about the concept of time. And another thing, well, let me just set this up. Where's my mouse? There we go. Okay, just taking my last sip of water. Now, the next issue or topic that I need to deal with is obviously, as written here, the size of the population, or size of the populations, or population sizes over the blips, or the overall relative sizes of populations when compared to pseudo-chaotic genetic algorithm. Because keep in mind, 400 for max pop, 400 was okay. It worked decently well for pseudo chaotic, but because of the reasons that I mentioned in my last video, because well, mainly one of them being that the overhead or slash cost of running an executable is too high, or is quite high, let's just say. Executable in this case would be a .bin file. So the cost is quite high, and therefore I cannot set the max population above or equal to 300, because then my laptop would probably just launch into the atmosphere, or maybe at least hover, because the fans would just be roaring, trying to cool down the device. So because of that, 100, or at most 200, anything in between. But when I set it like this, because of the sheer number of all the possible combinations that one could get when I have 100 items, 100 genes, let's just stick to items, is this number. So that's 30 zeros after this. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have this many. I don't even know how I would read this number. We have this many combinations, this many possible entities, different unique entities that could exist. And from all those times that I've run dynamic genetic algorithm, so far I have around 400 plus true ceilings, which is still a very, very tiny amount. So 400 divided by, divided by this number, whatever this number is what? Get rid of that. Actually, is that remove 2 zeros and divide this by 3. I mean 4. So that's around 315, which is still a huge number. So far, it's 1 in this huge number. So that it is absolutely massive, or rather is infinitesimally small. Is that the right word? I think this would just depict it right. Oops, let's not do that. Ah! God damn it. No, did I just lose all of that? Oh, I'm so bad. So anyway, it is very small, because it is still 400 plus divided by this number. That doesn't capture it well. So it's very small. So when I have 100 as the max population, maximum number of entities that could exist, although the current population in each blib may sometimes be above 100, so something like 113, 118, 123, and then entities would all just decide to get limited out of the population, and then the current population during a blip would just suddenly fall down to 70 or even 60, you know, etc. etc, etc, etc. But when I have it 100, back to the point, the number of entities, such a small number of entities, do not guarantee the variety or diversity needed, or that you would need to reach a true ceiling. And I'm quite sure that if I could actually set this to 400, I might start getting some true ceilings. But like I said over and over again, 300 plus, not possible without breaking, or let's just say bricking, my laptop. Yeah. And one way to do this, one way to actually tackle this problem would be to actually optimize the code, optimize code, and learn more about computers in general, or how they work, and all of that good jazz. With yeah, and then I thought, and then one might think that maybe it's to compensate for such a relatively low maximum population, 100. To compensate for this, what if I do max pop 100, but increase the maximum number of blips, the total blips, right? Do I call it max blip? Yeah, I call it max blip. Max blip. So keep the maximum population at 100, but increase the maximum blip from 100 to maybe 200, 300, 400, 500, and on and on and on. Which I think does help a bit, as as I have seen when I do, helps a bit when doing chaotic gen algo, but so far not so much. Maybe not so much when doing chaotic dynamic gen algo. And the reason for this would be that this is just now purely maybe, but most likely because of the maximum population being too low. Again, due to low max pop. Yeah, and of course I still have hope that with the right with the right hyperparameters, let's just say hyperparameters, I could or rather true ceiling may be possible, but I still have to run a lot more tests to find out. One issue is that it's because of the way that I made everything. It's trickier to run things multiple times in a row. Yeah, so I might need to refashion the code. Yeah. And I cover that. Refashion the code. Progress and randomness and so that does what? Yeah. All of this. Refashion the code so that I can maybe have more entities and maybe run things for multiple times in a row. These two things. Yeah. Also coming back, if I want to talk a bit more about blips, I think I might also need to find out the relationship or ships between blips. Let's just put it this way: sand grains, blips, population, and the number of data points for the summed util plots. Well, and this is due to the fact that if I set the maximum blips to 100, the number of data points is not going to be 100, and that is because of these sand grains, because each blip does not guarantee that the world.bin gets a record, gets one record in that blip. Most likely it is that for each sand grain used, or for each blip that passes, I may get probably like 10 data points, or even 20 data points, depending on how many sand grains that I create in the world.bin. Yeah. So, and so far, and the very first version created sand grains, well, calculated the number of sand grains to be created by multiplying the current population by 2, and then I changed that by 3, and then I also tried times 6, and then I also came up with a slightly more convoluted way of calculating, which would adapt to the number of items that are in question. And when I say the number of items, I also mean the number of entities that may exist during that era, because usually more items mean more entities, yeah. And I tried well, what did I try? First I tried longer, or no, actually, first I tried, here's what I tried: more sand grains for lower number of items, leading to fewer sand grains for higher number items. And the logic behind this was that if the entities and the number of items were to grow in a linear fashion, like that, like this, and because the true ceiling or the true ceilings usually entail or include the true ceilings for a smaller number of items, usually, it is quite likely, and because of that fact, I thought it might be quite important, and it is, but it might be more important for the entities to have converged during the initial first few eras, and then maybe that would guarantee that I on a consistent basis get entities that reach the true ceilings in each era, or maybe reach the true ceilings more. It might not do so in one era, but as it moves on to the next era, all the entities that are born may find it easier to reach the true ceilings. So that was the logic behind this. Turns out I was half right, half wrong. So if I was half right and half wrong, what should I do? So I went and gave fewer sand grains for higher, for lower number of items, and more sand grains for higher number of items. The logic here was that obviously if the number of items in question is higher, you need more entities. Since this was not an option, in order to mimic that, I needed the entities to be able to do more, to be allowed to do more as they exist. Entities as a group, not individual entities who get struck out or limited out, but entities as a group. They needed to be able to stay in an era, or in eras that deal with a relatively high number of items. So in that instance, it would be something like this. Give me the sky blue or turquoise. For a short period of time, it would be for 10 items. No, that's not short enough. Short period of time, 10 items, and then slightly longer 20, slightly longer 30, slightly longer 40, 50, longer for 60, 70, 70, 80, 90, and 100. So it's longer, 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 something like that. I know this isn't exactly longer, but you get the point. And in this case, sadly, I was again half right, and I was half right here. So which left me with no options but to actually allow just more sand grains overall, which is why I ended up doing times 6 the number of entities that exist at that point in time. But I do need to know now, in this new setting that is chaotic dynamic genetic algorithm, now I need to know for each number of items, now I need to know when the entities converge. This might be for 10 items, this might be 20, no, that's 2, this might be 20, this might be 30, give me bigger, yeah, this might be 50, no, 40, 50, 50, 60, 60, 70, 70, and on and on and on. And I may need to get in well, somewhat of a general idea of when they actually converge at each number of items, given all these different number of items, and then incorporate these findings into making or into creating the right number of sand grains at the start of each blip. Yeah. So that's one thing that I need to do. Another thing that I need to do. Trade off yeah, and another thing. Again, there are so many things that I need to talk about. No wonder it took me 17 days to just wrap my head around this. I'm just going to talk briefly about entity events now. I should. So, MLP. And this is mutate, this is learn, this is procreate. Usually mutation, it provides randomness. Oh my god. Mutation provides randomness. But because all the genes start as because all the entities start with void genes, mutation is absolutely necessary. Because without mutation, without those initial mutations, there's no progress. There's no change, no progress, no evolution. So randomness, it promotes or it provides first, but it does, as a result of that, it is the very thing that ignites progress or evolution. Progress and evolution, rather. Learning, it does not mainly provide or yield or promote randomness. It provides progress because an entity is learning from another entity that is supposedly doing better for that blip or for that in that era. But there is a bit of randomness, which comes from, which may or may not come from how the how an entity chooses which entity to learn from. So I have this, and if an entity will choose so far from another entity to learn from by determining which entities are the top 10% and ignoring the rest. It'll just choose from one of these entities that are in the top 10%. Now, this is how it had been for a very long time. And then just recently I named this value as the elite percentage, elite perk, and this is how it was done. The elite percentage or the elite perk was set to 10%, and I just ignore the rest, the 90%, when it comes to choosing an entity to learn from. But because again we come back to the max population being 100, and regardless of what values I set for the hyperparameters, all the entities were very hyperconverged, and yet not reaching one, not reaching a single true ceiling for the when doing chaotic dynamic genetic algorithm. So the next thing I did was increase the elite percentage from 10 to 20. Now it's 20%. And then I would get this. And ignore the rest, which is 80%. So what this does is it promotes more diversity. It guarantees higher diversity, higher level of diversity. Diversity is, in most cases, a decent level of diversity is good, because it stops a sudden extinction, as more than the desired number of entities, more than the appropriate or more than the preferred number of entities may just be struck out, and then you'd suddenly be left with half the number of entities that used to be there previously. So 20% elite percentage increase from 10% to 20%. That's one thing I did. And then very recently I compromised, or I compromised and I ended up adopting a ReLU-like function, a ReLU-like method for setting the weights by which these elite entities could be chosen. So this would be the head entity. This would be, for example, if the elite percentage is set to 15%, and there are 100 entities, this would be the rank 15. This would be the head entity being rank, meaning it's rank 1. So, and any entity would have, well, these weights would be relative, so they can all add up to more than 1. But the head entity is the one that is most likely to be chosen, and the one after that is maybe slightly less likely, and on and on and on until what the elite percentage is set to, which in this case is 15%. So rank 15. I could set this to 10, and then it would be here. I could set this to 5, and then it would be here. I could set this to 1, and then it could be here, or no, actually just here, whatever. And I could set this to 100, it would be here. So more flexible when it comes to setting the weights for the entities who are to be learned from. I kind of want to call them mentors, or teachers, or mentors. So anyway, the learn function, the learn method of an entity also does have some randomness in it. It just depends on what the randomness leads to, which entity it leads to. Then again, I would still love to have more than 100 entities. I would still love to have 400 entities running, entity processes running. And Procreate, when it comes to Procreate, it also promotes randomness first, because, I'm using the random selection Procreate function. And in a weird twist, not maybe that weird, or maybe not even a twist, it does, not as much as it does for randomness, but it does provide some level of progress, because, well, procreate means more entities, and more entities mean more mutation, which may potentially make room for more progress. Or it could also mean more entities that learn from elites. So what I want to say here, what I'm trying to get at here, is that although the entity event ratio, they kind of cancel out each other because they're all relative or comparative weights when I use the random dot choices method. There are trade-offs, of course, because they are relative weights. Because of that, there are trade-offs, but there are also there's also some kind of a reciprocal relationship, or there are reciprocal relationships between these three entity events. So I have to look out for such relationships, for such side effect relationships or influence, whatever. I need to keep that in mind when I need to keep this in mind when setting the entity event ratios, because I can't just suppose I had like 40, 20 and 5 as in percent, and then that's 65 and 35 for chill. Suppose this was the case, this was the initial case, and then I wanted more quote-unquote progress or evolution. No, maybe actually just progress, because progress does not necessarily mean evolution. But anyway, I want more progress, so it doesn't mean that I can just swap these two values, because this may mean not really more progress. And of course, all of this is given max pop tiny, and the effect, or the undesired effect, or the effect that I expected but didn't get is seems to be more amplified. Because if I lower the mutation rate from the start, because for now the hyperparameters are just fixed. If I have the mutation rate lowered from, for example, in this case 40 to 20, the initial entities do not mutate as much, and therefore they will have very low summed utility values, summed utility scores. But in the meantime, there's just learning from so-called elites. But again, keep in mind that even these elites did not mutate much, not much. So there isn't actually learning, there isn't actually much to learn, and learning for the other entities that are not in the elite won't do them a lot of good. So although just because mutation, no, just because learning, mutating and procreating, just because learning promotes progress or higher utility values, I can't just lower mutation. Maybe I could lower it by 10 or 10 points, maybe, or keep this 40 and have everything go over 100, in which case the ratios are not what they seem. But that's the whole point, that's the whole gist of it. I cannot simply raise or lower these values and get the intended results. So I also need to observe and study this relationship or relationships. Oh my god, I should have typed relationships. Yeah, so this is about it, and there's so many things to do for me to work on in a more systematic manner, because for the last 17 days I've just been doing things, just fooling around in a way, experimenting, and not exactly keeping record. But this is basically what I'll be doing, and making the next few videos about. Yeah, sounds daunting, exhausting and daunting, and yeah, well, wish me luck. I really need to buy a notepad. Okay, thank you for watching. Goodbye. Bye.